Okay, so we're going to practice more factoring and finding the GCF. So here we have example 7, factor each expression. So like we did before, we're going to first look for the greatest common factor here. Okay, so let's look at 7a. We have 8x squared minus 4. So you look at all the terms. We have 8x squared, we have a 4, and we look to see what number they have in common, right? Well, I like to look at the number parts first. So from 8x squared, the coefficient or the number is 8. And then from the 4, it's a constant. So it's a 4. So looking at those two number parts, the 8 and the 4, what is their greatest common factor? Well, they have a 2 in common, but that's not the greatest because I know they also both have a 4 in common. And that's the biggest one that I can pull out. So they have a 4. And now we can go back and look at the variable parts. Well, only the 8x squared has a variable part. That's the x squared. The other term is a constant. There is no variable. So they have no variables in common, just the 4. So the GCF here is 4. So again, I'm going to go ahead and undo the distributive property. I'm going to divide everything here, these terms, by that GCF, which is 4, and then I write what's left after dividing. So I wrote the 4, open parentheses, and now let's divide. So 8x squared divided by 4, well, 8 divided by 4 is 2, and then I have the x squared left. And then I have a 4 divided by 4, it's minus. 4 divided by 4 is 1. So that's what I get after doing that. Okay, so you find their greatest common factor, and we pull it out or divide everything by that greatest common factor and write what's left. Okay, so I'm going to go ahead and skip to part C now. Let's look at that one. 4xy minus 3y squared plus 19y. So again, I like to look at the number parts first, or the coefficients here. Okay, so what are those? Well, the first term, 4xy, I'm going to look at the 4. 3y squared, it's a minus 3, the 3. And then 19y, 19. What do they all have in common? Well, I know 3 is prime, so it just has 1 and 3 as factors. So 3 does not go into 4 evenly, or 19, so that's not going to work. 19 is also prime. It only has 1 and 19 as factors. So I can only divide that evenly by 19, but none of the other ones do. So there's no number part or coefficient that they all have in common. So let's look at the variable part. So I have an xy, I have a y squared, and I have a y. Do they all have variables in common? And actually, yes, they all have a y. 4xy has a y squared, that's 2y's, y times y, right? And then 19y has a y. So they all have at least a y. So the GCF is y. You can write that as 1y, or just the y if you want. Okay, so now I'm going to pull out the y, write that GCF, open parentheses, and I'm going to write what I get from dividing all of these by the y. Okay. So 4xy divided by y, well, those y terms cancel, leaves me 4x. 3y squared divided by y, well, one rule when we're dividing the same variables is to subtract their power. So y squared power is 2, y power is 1. So I can subtract 2 minus 1 is 1, or 1y minus 3 and just 1y. And then 19y divided by y, again, those y's cancel, so it gives me plus 19. So that's when I get when I divide everything by that greatest common factor. Okay, so we would normally have to check what's left. So 4x minus 3y plus 19. We would have to check to see if that can't be factored anymore. But you're going to go over that in another section coming up. So for now, we're just pulling out the greatest common factor and writing what's left. Okay, so now part D, I have negative x squared minus 6x plus 4. So again, looking at the coefficients or the number parts, do they all have something in common? Okay, other than 1, because we know everything divides by 1, but what else other than 1? Well, if I look at the first coefficient, it's a negative 1. Then over here I have minus 6. We're looking at the 6. And then we have a 4. Well, the first coefficient is a 1, so it's only going to divide by 1. And I said if they have anything other than 1 in common. So the number parts don't have anything in common other than 1. And if we look at the variable parts, well, we have an x squared, we have an x, those both have an x, but the constant doesn't. So I cannot pull out a variable term from all of them. They don't all have a common variable part either. So there's no greatest common factor here. But when your first term is a negative, it'll help you with the methods we're going to learn in the future to not have a negative as the first term. So it'll help us to have a positive. So how could I do that and make that a positive? Well, by dividing it by a negative, right? So in this case, it's a -1 that I'm going to pull out, okay? So I'm going to do like we were doing before, but use a -1. Divide everything by a -1. And again, this is because our first term is a negative, right there, the negative, and it's going to help us to use a positive first term. So when I divide by -1, open parentheses, all my terms get divided by -1. And essentially that just changes all of our signs. So -x squared divided by -1, a negative divided by a negative is a positive, so that makes it a positive x squared. The next term is a -6x divided by a -1. Well, it's going to make it a positive 6x. And the last term is a 4 divided by a -1, and that's going to make it a -4 because a positive divided by a negative is a negative. When you have two terms that are the same sign, like the other terms, negative divided by negative, you get a positive. So that's something also to keep in mind. You might think, well, they didn't have anything in common, but let's go ahead and still factor out a -1 if the first term is negative. Okay. Moving on to example 8. Let's look at B. Okay, same strategy from before. I'm going to look at the coefficients or the number parts first and then the variable parts. So I have 21x to the fourth minus 18x to the third plus 27x squared. So first looking at the 21, 18, and 27. I know that all of these have a 3 that I can divide them all by. So again, remember your methods from before. You can also maybe use the factor tree to help you get the factors if you're not as familiar with your multiplication facts. So keep that in mind. But looking at these numbers, I know that I can divide them all by a 3. So I have a 3 in common for all those coefficients. But what about the variable parts? Okay, I have an x to the fourth, power of 4. I have an x to the third, x to the power of 3, and an x squared. So they are all the same variable. So I'm looking to see how many of that variable can I pull out of all of them. Okay, well, one way to think about it, I'm going to expand them. So x to the fourth is 4x's being multiplied. X to the third is 3x's being multiplied. And x squared is 2x's being multiplied. So maybe that kind of helps you see better. I see that all of them have at least 2 x's that I can divide them by or pull out, right? So x times x is x squared. So the GCF here is 3x squared. Okay, so I'm going to divide everything by that 3x squared. So I write that in parentheses is what I get after I do that division, right? So let me clear this out. Let's divide every term by this GCF 3x squared. Divide by 3x squared. Divide by 3x squared. Okay, so 21 divided by 3 is 7. X to the fourth divided by x squared. So that shortcut is, again, we can subtract the powers. So 4 minus 2 is 2, so x squared. Let me show you that another way. You have 4x's, x to the fourth, divided by the x squared, which is 2x's. Okay, so this is x to the fourth on top, x squared on bottom. You can see that an x and an x cancel, another x and an x cancel, right? And what's left? You're left with 2x's being multiplied on top, or x squared. So just to kind of show you that visually, but again, the shortcut is to subtract those powers, okay? Let's look at the next one. It's minus 18x to the third divided by 3x squared. Well, 18 divided by 3 is 6. X to the third divided by x squared. Again, if I do the shortcut and subtract the powers, it's 3 minus 2, which is 1. So x to the first. And the last one, 27x squared divided by 3x squared. Well, 27 divided by 3 is 9. And x squared divided by x squared, it's the same number. So it cancels and gives me just a 1. So it's 9 times 1, or just 9. Another way to look at that with the shortcut, right? Remember I told you that the shortcut is to subtract the powers. Well, 2 minus 2 is 0, so you get x to the 0. Well, what is that? Well, again, looking at it another way, x squared over x squared is the same. So it would cancel and give me 1. So x to the 0 is 1. If we're looking at that rule of powers, that kind of is another way to look at that. So that's a concept that'll come up a little bit later, but keep that in mind, okay? Okay, so here we have that one right here. Keep in mind you can always check your work on some of these to make sure you divided it correctly. Anytime you wanted to check your work, you can go back and multiply that number times each of these terms, and you should get your original. So if you wanted to check, keep that in mind. That's one way to go back and see that you get the original expression that we started with, right? So here, 3x squared times 7x squared, 3 times 7 is 21. And x squared times x squared, now we add the powers when we're multiplying, is x to the fourth. 3x squared times negative 6x is going to be negative 18, x to the third, because we add the powers. And then 3x squared times 9 is going to be 27x squared. So you can check that to the original one and see that those are the same. Okay, so that helps that we did that one. Okay, let's look at the last one now. 4 minus 2x squared plus x squared y to the third minus 2y to the third. Again, let's look at all our numbers. So I have a 4, a 2, a 1, and a negative 2. So because I have the 1, that's as high as I'm going to go. I'm not going to have anything higher than that 1 in common. So from the numbers, I don't have anything that is common to all of them. What about the variable parts? Well, the second term has an x squared, and so does that third term. But the last term only has y's, and the first term has no variable parts. So it has to be something common to every single term, and not every single term has the same variable, right? So we're going to say that this one actually cannot be factored with the GCF, okay? Now, there's other ways to factor that we're going to look at later, so there might be something else that works. But for right now, I can't pull out a GCF, so we're going to go ahead and say it cannot be factored. So we look at what's in the box here. It says example 8, the GCF is just a 1. So factoring a GCF is not going to work here. A second method will be used, factoring by grouping, and you will look at this method coming in a few sections ahead.